In September 1998 in Cambridge, Acorn Computers, the company that had taught a generation to code, closed its workstation division. The hardware platform was dead. The desktop machines that had dominated British school ICT rooms for a decade were finished. The Cambridge offices were cleared, and the corporate empire effectively collapsed. Teachers lost their trusted classroom computers. Developers lost their hardware base. The British education market now belonged entirely to the global Windows PC. Usually when a computer company dies, its operating system dies with it. But inside Acorn's machines lived RISC OS, an operating system so fast it ran entirely from a ROM chip. The hardware vanished. The software refused to disappear. It continued to be updated, licensed, and fiercely preserved by the community it left behind. But the real story of RISC OS is not only the story of how a company abandoned its computers, it is the story of how a piece of British software was so efficient and so deeply embedded in a generation's habits that it outlived the empire that built it. Every week we tell the stories of British machines, platforms, shops, software houses, and screens that once taught the country what the future felt like, and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific necessity inside an Acorn Computers engineering lab in Cambridge in 1987. By the mid-1980s, Acorn Computers essentially owned the British classroom. The BBC Micro, a sturdy home computer designed to fulfill a public service broadcasting initiative, sat on desks in primary and secondary schools across the country, surrounded by eager pupils and cassette tapes. It had taught a generation how to write code, but by 1985, the technology was undeniably aging. The BBC Micro was an 8-bit machine. Its processor could only handle small chunks of data at a time, which severely limited memory, graphics, and the complexity of the software it could run. Acorn needed a successor. The company's engineers in Cambridge examined the processors available on the open market and found them either too slow, too expensive, or too complicated. So in a move of extraordinary ambition, Acorn designed its own. The result was the ARM processor, a chip built to be incredibly fast, structurally simple, and highly efficient. But a revolutionary chip is useless without instructions. A processor, the main chip that performs calculations and executes tasks, cannot interact with a pupil or a teacher on its own. It requires an operating system, the core software that manages the hardware, draws the screen, and lets other programs run. This was Acorn's crisis as they approached 1987. They had built a machine of the future, the Acorn Archimedes, but they did not have a modern operating system ready to power it. The global market was already shifting. The IBM-compatible personal computer was spreading through offices, largely relying on MS-DOS, a system where users typed text commands onto a stark black screen. Meanwhile, in America, Apple had introduced the Macintosh, which used a mouse to manipulate windows and icons, but it was far too expensive for British local education authorities or typical high street shoppers. Britain needed something different. A British school computer needed to be powerful enough to handle advanced mathematics and design, graphical enough to engage primary school children, and robust enough to survive a classroom environment where 30 pupils might share a single machine. Under immense pressure to meet a production deadline, the Cambridge team rushed out a stopgap operating system. They called it Arthur. When the first Archimedes computers arrived in the UK market in June 1987, they booted into Arthur. It provided a graphical desktop, but it was visibly unpolished. The interface featured a notoriously garish color palette of harsh reds and yellows. More importantly, it lacked true multitasking, meaning it struggled to run multiple tasks at the same time smoothly. Arthur proved that the Archimedes worked, but it did not feel like the definitive operating system of a new era. It felt like a hurried coat of paint over an older world. The hardware was brilliant, but to truly dominate the British ecosystem again, Acorn needed a software breakthrough. The team at Cambridge knew Arthur could not hold the market. They immediately began writing its replacement. It took nearly 2 years of relentless engineering, but in April 1989, Acorn released the true operating system for the Archimedes. They renamed it RISC OS, launching with version 2.0. The name stood for Reduced Instruction Set Computer, directly referencing the philosophy behind the ARM chip that powered it. This was not just an update, it was a complete structural transformation. RISC OS 2 delivered a refined, professionally presented graphical desktop that suddenly made the IBM-compatible PCs of the era look primitive. But its greatest strength was not merely aesthetic, it was physical. In the late 1980s, most operating systems loaded from a floppy disk, a removable magnetic storage format, or a slow, noisy mechanical hard drive. When a user turned on an IBM PC, they had to wait as the machine read the core software from a spinning disk into the computer's memory. Acorn took a radically different approach. RISC OS was not installed on a drive. It was burned directly onto physical silicon. It lived entirely on ROM chips. Read-only memory, a type of permanent physical storage where data is written during manufacturing and cannot be easily erased or altered. These chips were plugged directly into the computer's motherboard. To understand why this mattered, you have to look at a typical British comprehensive school in 1989. In a standard ICT lesson, a teacher had exactly 45 minutes to settle a room of 30 restless pupils, get them logged onto the machines, explain the task, and ensure everyone saved their work before the bell rang. If a room full of computers took 3 minutes to boot up from slow network drives or floppy disks, a significant portion of the lesson was lost simply waiting for the machines to wake up. Because RISC OS lived on ROM chips, an Acorn machine did not boot in the traditional sense. When a teacher pressed the power button, the computer simply switched on. It was ready in seconds. The desktop appeared almost instantly, snapping onto the heavy CRT monitor with a reassuring click. This architectural decision created a user experience that felt like magic. The operating system was completely immune to software corruption. A pupil could not accidentally delete the core system files because those files were physically etched into silicon. If a machine crashed or a pupil typed something disastrous, the teacher simply reached around to the back, flicked the power switch off and on again, and the machine instantly returned to a pristine desktop. But RISC OS 2 needed a physical vessel that schools could actually afford. The original Archimedes models from 1987 were expensive, multi-piece professional workstations. To recapture the territory lost by the aging BBC Micro, Acorn needed a machine designed specifically for the school desk. In May 1989, just weeks after finishing RISC OS 2, Acorn launched the A3000. It was a masterpiece of British tech packaging. Priced at $649, it squeezed the immense power of the ARM processor and the sheer speed of the RISC OS ROM chips into a single wedge-shaped beige case with an integrated keyboard. The A3000 became the Trojan horse for RISC OS. When local education authorities across Britain began testing the machine, they found an environment that was both familiar and entirely alien. It still included BBC Basic, the programming language that British teachers had relied on for a decade. A teacher could press the F12 key on the A3000, and the sophisticated graphical desktop would slide down the screen, revealing a simple command line ready for pupils to type the exact same code they had used on the old BBC Micro. This backwards compatibility was a masterstroke. It assured nervous head teachers that their previous investment in computer literacy would not be wasted. Yet when the pupil typed desktop and pressed return, they were instantly transported back to a windowed, multitasking environment that felt light years ahead of the corporate world. Acorn had built the hardware to escape the 8-bit past. Now they had an operating system that made the future visible. The A3000 brought the Archimedes hardware to the desk, but RISC OS was what kept the pupil in the chair. To understand how radical this software was, you have to look at what the rest of the world was using. In 1990, if you walked into a British corporate office or a high street bank, you would likely find an IBM-compatible personal computer. These machines relied heavily on MS-DOS, a command-line operating system where users stared at a stark, black screen and had to memorize and type exact text commands to make the machine do anything. It was powerful for business, but it was cold, abstract, and deeply hostile to a 10-year-old pupil. RISC OS, by contrast, offered a graphical user interface, or GUI, a visual way of interacting with a computer using a mouse, pointers, and windows. Apple had already popularized this concept in America with the Macintosh, but Acorn brought it to the British masses with fiercely original engineering. RISC OS did not simply copy Apple or Microsoft. It built its own logic, tailored specifically for an environment where speed and clarity mattered more than corporate conformity. The most immediate shock to a new user was the icon bar. Running along the bottom of the heavy CRT monitor was a dedicated graphical shelf. If you inserted a floppy disk, a removable magnetic storage format used to load files and games, its drive icon appeared on the left side of the bar. If you opened a software program, its icon appeared on the right. The icon bar was a visual anchor. 6 years before Microsoft introduced the Windows 95 taskbar to the global market, British schoolchildren and teachers were already using a superior, highly visual dock to manage their digital space. Then there was the physical interaction. Acorn rejected the single-button mouse of the Apple Macintosh and the two-button standard of the PC. A RISC OS machine used a three-button mouse, and each button had a strict logical name: select, menu, and adjust. Select, the left button, clicked on items, but the middle button, menu, was a revelation. Instead of forcing the user to drag the pointer all the way to the top of the screen to find a drop-down menu, clicking the middle button opened a context-sensitive menu directly under the cursor, exactly where the user was looking. The right button, adjust, was used to modify a selection or, brilliantly, to click a Windows close button while leaving the parent directory open. It was an interface designed to minimize wasted movement. This physical logic extended into how data moved across the screen. By 1990, RISC OS featured system-wide drag and drop. In the IBM PC world, saving a file often meant navigating a rigid hierarchy by typing a file path like cdocswork.txt. On RISC OS, a pupil simply clicked the Save icon inside a document window, dragged it across the screen, and dropped it directly onto a floppy disk icon on the icon bar. The file was saved. The operating system turned abstract data management into a physical, tactile action that made immediate sense to a child in a classroom. This fluidity relied on true cooperative multitasking. The ability of an operating system to run multiple programs at the same time without freezing the machine. A pupil could have a word processor open, run a geometry program, and leave a drawing app sitting on the icon bar, switching between them instantly. Because the core system lived on a fast ROM chip rather than a slow hard drive, the machine rarely felt sluggish. RISC OS also featured an advanced font engine that smoothed the jagged edges of text on the screen, making documents look professionally printed long before desktop publishing became standard in homes. But the greatest stroke of engineering genius in RISC OS was entirely hidden from the casual user. It was the way it handled software architecture. In the Windows ecosystem, installing software, transferring a program onto a computer so it can run, meant copying files into various hidden system folders, altering complex registries, and hoping nothing broke in the process. Over time, PCs became clogged and slow. Acorn invented something entirely different: the application directory. On RISC OS, an application was simply a folder that began with an exclamation mark, universally known in the British tech community as a pling. Software like Paint or Draw was just a directory containing all of its own code, visual sprites, and data. When a user double-clicked the folder, the operating system treated it as a single executable program and ran it. This completely eliminated the concept of an installation wizard. To install a program on RISC OS, a teacher or pupil simply dragged the pling folder onto their hard drive. To uninstall it, they deleted the folder. To back it up, they dragged it to a floppy disk. There was no registry to corrupt. There were no hidden system files to accidentally delete. It was a masterpiece of software architecture that prevented the operating system from ever decaying. The interface was a triumph of British engineering. It was logical, visually striking, and structurally superior to the rigid systems dominating the global corporate market. The code was brilliant. But a British computer needed more than elegant code to survive. It needed a classroom to live in. By the early 1990s, RISC OS was no longer just an ambitious piece of code living in Cambridge. It was the digital foundation of the British educational system. The Acorn A3000 had done its job, securing the classroom desk, but the platform was rapidly expanding. Acorn introduced the A4000, And in 1994, the RISC PC, a highly expandable modular computer that allowed users to stack physical plastic slices on top of each other to add CD-ROM drives or extra hardware. In a British school ICT room, the operating system was not just an interface. It decided how quickly a lesson began, how a pupil understood a file, and whether computing felt like a creative space or a corporate chore. When local education authorities across the UK purchased these machines, they were buying into a closed, highly optimized ecosystem. The network holding them together was often Econet, Acorn's proprietary local area network system, which allowed an entire classroom of computers to share a single hard drive and a dot matrix printer. A pupil would sit down, turn on the machine, watch RISC OS snap instantly onto the CRT monitor from its ROM chip, and log into the shared network. There was no waiting for a heavy operating system to load. The machine was simply ready. This guaranteed captive audience of millions of British schoolchildren created a goldmine for independent software houses. Because RISC OS was so fiercely efficient, developers could build applications that perform miracles on relatively modest hardware. The pages of British computer magazines like Acorn User and Archive were filled with mail-order adverts for software that simply could not exist in the same way on a standard MS-DOS or early Windows PC. Computer Concepts, a legendary British software house, released Impression, a desktop publishing program. Desktop publishing, software used to lay out text and graphics for print, was notoriously slow on IBM PCs, requiring expensive Apple Macintosh machines to do properly. But on RISC OS, Impression ran with blinding speed. Pupils and teachers could drag and drop text frames, scale images in real time, and print school newsletters without the machine freezing. It turned the Acorn machine into a professional design studio. Even more astonishing was Artworks, a vector graphics package also developed by Computer Concepts. Vector graphics, images built using mathematical formulas rather than a fixed grid of colored pixels, allowed users to zoom in infinitely without losing quality. On a standard PC in the early 90s, rendering a complex vector drawing was a sluggish, stop-start process. On an Acorn machine running RISC OS, Artworks rendered illustrations almost instantly. The operating system's cooperative multitasking meant a pupil could leave a heavy render running in a background window, click over to a word processor, and keep typing without a single stutter. But the absolute crown jewel of the YE RISC OS ecosystem came from two British brothers, Ben and Jonathan Finn. In 1993, they launched Sibelius, a music notation program. Sibelius was written entirely in ARM assembly language, the deepest, most direct way for a programmer to speak to the processor, specifically for RISC OS. Music notation requires immense processing power to play back multiple orchestral parts while simultaneously scrolling a complex graphical score across the screen. On an Acorn machine, Sibelius 7 performed flawlessly. It was so far ahead of any music software available on Windows or Mac that professional composers, universities, and music departments across Britain bought Acorn Computers for the sole purpose of running it. Sibelius was a killer app, a piece of software so essential that it justified the purchase of the entire hardware platform beneath it. This was the glory of RISC OS. It was not trying to be a corporate spreadsheet machine. It was a creative engine. It fostered a culture where computing was visual, immediate, and intensely productive. For a brief, golden window in the early 1990s, a British pupil could walk into an ICT room, click the middle button of their mouse to open a menu, and use software that outperformed the most expensive professional workstations in the world. The software houses had built a creative utopia on British silicon. But an operating system cannot survive on creativity alone. It needed sheer market volume to hold back the tide. By 1994, this software ecosystem found its ultimate physical form in the Acorn RISC PC. This was not the wedge-shaped keyboard computer of the late 80s. The RISC PC was a modular desktop machine built using stackable plastic slices. If a school or a professional designer needed to add a CD-ROM drive or extra hard drives, they simply bought another slice and clicked it on top of the case, expanding the machine vertically. But the true genius of the RISC PC lay in how RISC OS managed this hardware. Because the operating system was so incredibly lightweight, it had the capacity to perform tricks that seemed impossible on a standard machine. Acorn engineers knew that the IBM-compatible PC was dominating the corporate world, so they built a bridge. A user could buy a PC card, a physical circuit board containing an Intel 486 processor, and plug it directly into the RISC PC motherboard. Through the sheer efficiency of RISC OS, a user could run Microsoft Windows natively inside a standard RISC OS window. A British teacher could have a complex vector drawing open in Artworks on one side of the screen, and a full version of Windows running Microsoft Word on the other. They could drag the mouse between the two worlds effortlessly. It was a staggering display of software supremacy. RISC OS was not just surviving alongside the PC standard, it was swallowing it whole and putting it in a resizable box. This capability fostered a fierce, almost tribal loyalty. The community surrounding RISC OS was unlike any other in British technology. It was supported by local education authorities, the regional councils responsible for outfitting state schools, who trusted Acorn deeply because the company had delivered the BBC Micro a decade earlier. When a school's Econet network went down, teachers did not have to navigate a faceless global corporate help desk. They called the local council's IT support, who likely had an Acorn specialist on staff. Beyond the classroom, the British computer magazine industry, the paper internet before the web, treated RISC OS as a national treasure. On the shelves of W.H.S. Smith and John Menzies, magazines like Acorn User and RISC User thrived. They came with cover discs packed with freeware, utilities, and fonts created by a dedicated network of bedroom coders who loved the elegance of the ARM architecture. The peak of this culture was Acorn World, an annual exhibition often held at Wembley or other major exhibition centers. It was not a sterile corporate trade show. It was a sprawling, enthusiastic gathering of British teachers, independent software developers, pupils, and hobbyists. They wandered past stalls selling networking cables, educational games from British publishers like Shurston Software, and productivity tools neatly packaged in plastic cases. At its height in the mid-90s, this event proved that RISC OS was not merely an operating system. It was a completely self-sustaining British identity. For a comprehensive school pupil in 1995, the RISC OS desktop was often the most powerful digital environment they had ever touched. Primary school children could navigate complex directory structures without realizing they were learning data management. They double-clicked a pling folder, dragged a file to the floppy disk icon on the icon bar, and felt entirely in control of the machine. The software never degraded. The computer always booted instantly. This was the pinnacle of British educational computing. The hardware was built in Britain, the processor architecture was designed in Cambridge, the operating system was coded locally, and the software was written by British developers specifically for British schools. It was a perfect, closed loop. But this closed loop was a double-edged sword. The absolute loyalty of the educational market gave Acorn a comfortable, highly profitable fortress. In the mid-90s, Acorn still held a massive majority share of the UK primary school market. Yet the ecosystem relied entirely on this isolation. RISC OS did not need to fight Microsoft for the corporate office, because Acorn had the classroom. The British software houses did not need to port their applications to the global PC market, because British schools were still buying Acorn. The British classroom belonged to Acorn, but outside the school gates, a global standard was preparing to take the high street. The first crack in the RISC OS fortress was almost invisible. It did not start with a server crash, a hardware failure, or a sudden loss of school contracts in Cambridge. It started in 1992 with a software box on a high street retail shelf containing Microsoft Windows 3.1. Windows 3.1 was not a true operating system in the way RISC OS was. It was a graphical shell that sat awkwardly on top of the aging MS-DOS system. It was sluggish, prone to freezing, and completely lacked the elegant application directories and ROM-based stability of the Acorn machines. To a British pupil or teacher accustomed to the instant boot-up and cooperative multitasking of a RISC PC, Windows 3.1 felt incredibly clumsy. It still relied on a two-button mouse, lacked the intuitive drag-and-drop file saving of RISC OS, and required software to be installed through complicated, registry-altering wizards. But Windows 3.1 had one advantage that brilliant British engineering could not defeat. It ran on the IBM-compatible PC, a generic hardware standard manufactured by thousands of different companies globally. Because anyone could build a PC, competition drove the price of the hardware down dramatically. This was the brutal reality of Force 4. Global scale and American standards, Acorn was a British company building custom silicon and custom software for a primarily British educational market. Microsoft and Intel were building a standard for the entire planet. The pressure began to build not in the classroom, but in the British living room. By the early 1990s, the home computer was evolving from a bedroom gaming machine into a serious household utility. When a family walked into a Dixon's, Curry's, or PC World to buy a machine for the box room, they did not just want a computer for their children's homework. Parents wanted a machine that ran the same software they were using in their corporate offices. They wanted MS-DOS, WordPerfect, and Microsoft Excel. Suddenly, a disconnect appeared. A pupil would learn on an Acorn Archimedes at school, mastering the brilliant RISC OS interface and the three-button mouse, but go home to a beige PC running Microsoft software. The British educational ecosystem, once a unified front, was becoming an isolated island. The true turning point, however, arrived in August 1995. Microsoft launched Windows 95 with a global marketing campaign that treated a software update like a Hollywood film premiere. Windows 95 was a massive leap forward for the PC standard. It introduced the taskbar at the bottom of the screen, the Start menu, and system-wide drag-and-drop file management. To the global market, it felt like a revolution. To a British teacher who had been using a RISC OS since 1989, it simply looked like Microsoft had finally caught up to the Acorn icon bar. But being first did not matter anymore. Windows 95 wiped out the glaring visual and practical advantages that RISC OS had held for over half a decade. The PC was no longer just a cold business machine. It was now a viable, graphical multimedia computer. With the interface playing field leveled, the secondary trap closed in. This was Force 3, standards, ecosystems, and developer support. A computer is only as valuable as the software it can run. During the glory years, British independent software houses had loyally coded for RISC OS because the UK educational market was a guaranteed, captive revenue stream. But writing software in ARM assembly language for a bespoke British operating system required highly specialized knowledge. When Windows 95 exploded onto the market, these developers faced a harsh mathematical reality. A software house in Manchester or London could spend a year developing a brilliant educational program for RISC OS and sell it to a few thousand British schools. Or they could write the exact same program for Windows 95, put it on a CD-ROM, and instantly have access to tens of millions of PC users across the globe. The developers began to drift. British software publishers started porting their flagship titles to the PC. The pages of computer magazines began to change. Adverts for RISC OS software shrank, gradually replaced by double-page spreads for PC educational software and multimedia encyclopedias. Even the retail support systems that had propped up Acorn began to waver. National supermarket initiatives, like the famous Tesco Computers for Schools voucher scheme, had initially been a massive lifeline, heavily promoting Acorn machines to British classrooms. But as the decade wore on, the sheer demand from parents and school governors forced these schemes to offer multimedia PCs alongside the Acorns. The hardware was still fast. The code was still flawless. The icon bar still worked perfectly. But the ecosystem around the machine had quietly begun to bleed to death. As the late 1990s approached, the definition of computing in Britain shifted again. It was no longer just about writing code, publishing school newsletters, or creating vector graphics. It was about connecting to the outside world. The internet had arrived. The UK government launched massive funding initiatives like the National Grid for Learning, determined to wire every state school to the World Wide Web. This required a browser, software used to view websites. While RISC OS had highly capable British-built browsers like Fresco and Antweb, the global internet was increasingly being coded for Windows machines and American standards. This connectivity drive gave local education authorities the final excuse they needed to break their loyalty to Cambridge. The councils that had faithfully purchased Acorn machines for over a decade began to issue new purchasing mandates. They argued that pupils needed to be prepared for the modern corporate workplace, and the corporate workplace did not use a three-button mouse or application directories. It used Microsoft Office. The physical landscape of the British school computer room began to change. The beloved Archimedes and Risc PC machines were quietly unplugged, pushed to the back of the class, and eventually banished to storage cupboards, replaced by rows of generic beige PCs running Windows 95 and Windows 98. For a generation of British teachers who had spent 10 years mastering the elegance of RISC OS, it was a bitter moment. Their deep technical knowledge was suddenly declared obsolete by a government mandate. Stripped of its guaranteed school monopoly, Acorn's hardware division was bleeding money. The mathematics of Force 1, hardware, software, supply chains, and manufacturing costs were brutal. Acorn was a small British company trying to build custom motherboards and proprietary cases, while American giants like Dell and Compaq were churning out millions of cheap standardized PCs using global supply chains. Yet Acorn tried one last, desperate push. Throughout 1998, the company teased the Risc PC2, codenamed Phoebe. It was housed in a striking, bright yellow case, a defiant splash of color against the gray and beige PC world. For the loyal British enthusiast community, Phoebe was a beacon of hope. Pre-orders were taken. The computer magazines ran breathless previews. Fans prepared for the annual Acorn World exhibition, ready to buy the machine that would keep the British desktop alive. Then came the sudden, brutal shock of September 1998. The Acorn Board of Directors looked at the global desktop market and realized the war was unwinnable. Just days before Phoebe was supposed to enter mass production, the project was completely canceled. Acorn announced it was closing its workstation division. The hardware platform that had defined British computing, the lineage that stretched all the way back to the BBC Micro, was unceremoniously killed overnight. The paradox of this collapse was staggering. Force 5, corporate consolidation and foreign acquisition, tore the company apart, but not because Acorn was a complete failure. It was dismantled because one of its internal projects had become too successful. The ARM processor, with the chip originally designed in Cambridge simply to make RISC OS run faster, had escaped. It was now being licensed to manufacturers around the world to power a rapidly growing market of mobile phones and embedded devices. The chip division was worth an absolute fortune, while the desktop computer division was a financial liability. To satisfy shareholders, Acorn restructured, pivoted entirely to silicon development, changed its name, and was eventually broken up and absorbed by global tech capital. When a hardware company dies, its operating system almost always goes down with the ship, but RISC OS refused to disappear. The code was too fast and its users were too stubborn to accept defeat. Instead of dying, the software splintered. Acorn licensed RISC OS to Pace Microtechnology, a British company that wanted to use the hyper-efficient software inside set-top boxes, digital receivers for television broadcasts. At the same time, Castle Technology, another British firm, bought the rights to continue manufacturing specialized RISC OS desktop computers for the dedicated minority who refused to migrate to Windows. The operating system became a digital ghost. It was passed between holding companies, fractured by complex legal disputes, and kept alive by a fiercely loyal, aging community of British developers who continued to release software updates, patches, and magazine discs for a platform the high street had completely forgotten. The council mandates changed. The software houses followed the PC. The classroom machines booted into Windows. The yellow cases were never shipped. The Cambridge offices were cleared. The hardware platform died, but the code refused to stop. When Acorn collapsed in September 1998, the intellectual property rights to RISC OS became a notoriously complex legal labyrinth. The operating system was effectively orphaned, but it was far too valuable an engineering asset to simply delete. Because the code was so incredibly lightweight and required so little processing power to run a graphical interface, it found a strange, hidden afterlife. Acorn licensed RISC OS to Pace Microtechnology, a British firm that embedded the software into digital set-top boxes. For years, millions of British viewers navigating their digital television menus were unknowingly interacting with the direct descendant of the Archimedes classroom computer. But the desktop version, the true RISC OS that teachers, designers, and bedroom coders had loved, required a different kind of salvation. Castle Technology, a British hardware manufacturer, bought the rights to keep building dedicated machines, releasing the Ionix PC in 2002. This was a monumental task. The codebase had to be extensively modernized, transitioning fully to 32-bit architecture to support newer processors. Following this, the community fractured into a web of competing licenses, with entities like RISC OS and RISC OS Open taking on the immense burden of maintaining, patching, and updating the code. In a normal market, an operating system that loses its parent company dies within 12 months. The hardware ages out, the developers move to more profitable platforms, and the user base eventually buys a Windows machine. But RISC OS had the British enthusiast community. These were the teachers, the local council IT technicians, the software house veterans, and the bedroom coders who absolutely refused to surrender the sheer efficiency they had grown used to. They kept the ecosystem alive through sheer willpower. They organized physical events, most notably the Wakefield RISC OS show in West Yorkshire and the Southwest show. In local community halls and hotel conference rooms, independent developers continued to sell boxed software, networking cables, and utilities to a dedicated crowd. The British computer magazine Archive continued publishing for decades, mailing physical issues to subscribers long after the high street had completely cleared its computer shelves. This community did not keep the operating system alive as a museum piece behind glass. They kept it alive as a daily utility, writing new drivers and updating the code to work with modern internet protocols. This survival passes the highest threshold of technology preservation. Walk into the Center for Computing History in Cambridge, or the National Museum of Computing at Bletchley Park, and you will see these machines still running flawlessly. But it is not merely nostalgia for a yellowing beige box in a 1990s ICT room. The survival of RISC OS is an ongoing physical argument about the nature of modern computing. Today, if you buy a standard Windows or Apple personal computer, you are buying a machine burdened by decades of software bloat. Modern operating systems require gigabytes of memory, massive background registries, and billions of processor cycles just to draw a desktop, track user data, and open a web browser. RISC OS is a living masterclass in extreme software efficiency. It proves that an operating system can be lightweight, entirely logical, and completely free of hidden background processes. It reminds us that the concept of the application directory, where a program is just a folder you can drag onto a floppy disk without an installation wizard, was a superior way to handle data. The Acorn ecosystem did not fail because the code was bad. It failed because the global market chose the momentum of scale over the elegance of engineering. The ultimate surprise footnote to this history arrived in 2012. A group of Cambridge engineers, deeply inspired by the legacy of the BBC Micro and the Acorn computers they had used in their youth, released a tiny, incredibly cheap circuit board computer designed to get British children coding again. They called it the Raspberry Pi, because the Raspberry Pi was built around an ARM processor, the very chip architecture Acorn had invented in 1987 to run its machines. The hardware lineage had come full circle. The enthusiast community, led by RISC OS Open, successfully ported the operating system to the new device. Suddenly, a piece of software written for the British classrooms of the 1980s and 1990s was running natively on the most successful British computer of the 21st century. Acorn Computers lost the high street. The British classroom eventually surrendered to the global PC standard. The modular Risc PC was replaced by rows of generic beige boxes, and the 3-button mouse gave way to the 2-button standard. But the Cambridge engineers who built RISC OS achieved something incredibly rare in the history of technology. They wrote a piece of software so flawlessly fitted to its processor, so deeply understood by its developers, and so fiercely loved by its users, that it simply refused to accept its own obsolescence. Somewhere in Britain today, a tiny Raspberry Pi sits on a desk, wired to a modern flat-screen monitor. Without a mechanical hard drive, without a heavy loading screen, And without a single corporate installation wizard, it powers on instantly, snapping straight to a clean desktop with a familiar icon bar resting quietly at the bottom. See you in the next one.